Hi, my name is Jean-Luc. I am in CPE 100 with section 1002 100 lab, and my final project is a Morse code translator in game. So my project is a Morse code decoder. It has two modes, a translate mode and a game mode. The modes are toggled by a switch. When the switch is off, which is the default, the translate mode is active. Translate mode is default, and when the switch is on, the game mode is active. That means you can play the game that I've implemented. There are four entries, which are the values dot and dash, which are implemented by a switch. I'll show that in my demonstration. Next, which is a push button, which means that you actually enter the dot or dash value. Enter, which means that you've entered your entire sequence. And then reset, which just resets the entire system. My translate mode. For translate mode, the user inputs the Morse code sequence through a switch. After each dot or dash is entered, user must press a push button to register the input. So that means you enter, what you think the combination is, and then after you enter a dot or dash, you click the button, and it goes through the system. Once an entire sequence is entered, the user will turn another switch on. That means I've entered everything. I will show that in my demonstration. And then once that switch is turned on, the system will then detect whether or not that letter corresponds, or the Morse code sequence corresponds to a letter. And then once that letter is displayed on 7-segment display, you can either reset the entire system and retry another sequence, or go to the game mode. For the game mode, the user must guess the correct sequence for a given letter or number. So you are given the number, letter, there's no numbers. You are given the letter, and that is displayed on 7-segment display, and you have to input the correct Morse code sequence for that. If you do get that Morse code sequence correct, it will display on the four left-hand side 7-segment displays. Good will be displayed. That means that what the combination you entered was correct. There are 16 levels that are controlled by the switches, so kind of like binary. So if switch 1 and 4 are flipped on, level 9 will be played. And you can reset the game once you're done, and you can either play again, play a different level, try again, and or go back to the translate mode, which is the default mode. The goal of my project was to just create a device that takes in user enter Morse code and then display it two different ways. So one is translate, where the user inputs the Morse code, and then it finds the corresponding Morse code sequence to the input one. And then there's also a game where the user inputs the sequence that corresponds to the letter shown on the 7-segment display. It's the opposite of the translate mode. And I kind of combined these two ideas with the same theme into one project. So for background, I used a lot of D flip-flops because it was very important for me to be able to count the number of inputs, because some Morse code values are 1 bit, some of them are 4 bits, so I don't know exactly how many bits are going to be needed for the combinational logic to check if the Morse code sequence is correct. So D flip-flops are very important for that, for counters. I was also able to store the dot and dash values that the user entered. That was also very important for the combinational logic to check if the Morse code sequence is correct. I used the dot and dash with shift registers, so it pushed the dot and dashes through, and then once they were pushed through, I checked to see if the combinational logic was correct. The AND gates I used, to check if the entry matches the letter, talk specific level, etc. And I used a lot of OR gates for the outputs, because only certain combinations require certain segments of the 7-segment display. Like an A doesn't need the third segment on the 7-segment display, because that wouldn't display A, that would just display everything on the 7-segment display. So, as I'm showing here, this is the Morse code detector. This is just the general sequences that you have to use for most Morse code. It's very standard. This is what I used for implementing my Morse code detectors. And my schematic is very large. It's very complicated and very involved. So I'll actually show my schematic here. So this is what it all looks like as a kind of wide view. Up here, I have the combinational logic for each letter for detecting the sequence. So the sequence is entered here, the counter is entered here, and then it detects if the sequence matches any of these. If it does, it goes down here. It's the logic to display it on 7-segment display, and it'll display on the 7-segment display if one of these is found. Over here is my game mode. Here are my 16 different switch combinations which toggles levels. Each of these corresponds to the same thing up here. You know, there's the counter and then there's a user input. We have both of those. We have 16 of those, and then all those, if the output's correct, if the logic is correct, it outputs good here. And then also up here, it outputs the letter that you're trying to figure out from here when you select the level. Right here are my 4 inputs, which are standard, and they are used for both segments. So they're used for both modes. The same inputs are for the game mode and the translation mode. So I'll actually show my circuit operation. So we have my circuit here. You can see this is the enter. This is to flip on. This is dot. This is dash. This is the enter. So when the entire sequence is entered, you flip that up, and this is my reset. So if I enter dot dash and I flip up the enter, A will be entered. And if I just want to, maybe do a 4-bit, which is Z, I can do dash dash dot dot, Z is entered. And then for my game mode, let's flip on switch 3, which toggles the game mode, and let's just go to the last level, level 16, which is F. F, the sequence for F is dot dot dash dot. I can go dot dot dash dot, and then flip this up, and it says all good. So that means the display is, my sequence is correct, and then my game mode works as well. So I had a few problems. It was kind of hard figuring out the levels. I had it kind of integrated with the decoder, and that gave false readings because obviously when you enter something in the one section, it'll enter in the other section, and then it just kind of was a jumbled mess. So when I separated the functions, everything worked out. The modes both worked with having the same inputs. And then also how complex it is and how large the project was kind of made it hard to keep organized, and it was pretty time consuming. Some interesting information I found were shift registers very helpful for data entry because I didn't know exactly how many bits there would be, like I said before. So tracking how many times shift happens, I was able to accurately determine validity of the Morse code sequence entered by the user. And as a result of testing combinations, I've kind of learned Morse code a little bit. So as a conclusion, I've successfully implemented my own personal project, my DE0 board. My decoder can both translate Morse code, input letters, and I use my skills taught and practiced during the labs and combine them to create my decoder. I use concepts from basic combinational logic all the way to shift registers and D flip-flops.